I think this is the first time we've really had a car that had enough range and where the fuel cost per mile was less than gasoline. I think it's going to be well, actually the auto companies have reacted and they never have before, so I guess that's a positive sign.
So the giant is awakening.
Yes.
Maybe the glacier will stop.
Alas.
Are you having any problem with the not invented here syndrome, NIH?
You always do, but so far, reaction's been really positive. You know, with the zero emission vehicles being mandated, they've got to find something, and they're looking pretty hard. And then to have something that costs less to operate than gasoline, even if you plug into the grid. We can compete with gasoline head-on in price with a PV cell, photovoltaic cell. And I've never seen anyone really be able to do that before. Yeah, that's assuming, you amortize them over 7 years, but still, that's a big step.
7-year amortization.
Mm-hmm. Yeah, of course, that depends on how much driving you're doing and everything, but if you put PVs on your house and financed them on a home mortgage, you could actually drive your car for less fuel cost than if you went out and bought gasoline at the pump. It has over 100 plates stacked in it. Mm-hmm. Very thin. In fact, that's why we call it the laser cell. The canodes, as we call them, anode cathodes, are very, very thin because we manufacture them with a laser.
Okay.
And our last design ought to be about that tall for the same amount of power. Mm-hmm. So the laser has really helped the size, the weight, and the cost.
Boy, I guess so. In quantity, what would it cost to produce something like this? That's a question everybody asks, I suppose, and maybe there isn't an answer yet.
Well, we have an estimate. In a production run of 10,000 pieces, we're estimating $3,500 for the fuel cell.
Jeez,
and in the same quantity, the hydride and control systems, we're estimating another $1,000. So $4,500 for the system.
What's the maintenance on that?
Right now, the maintenance looks like it's going to be a plus. We have no moving parts. Our little compressor has a diaphragm that's actuated by the pressure in the hydride tank. And so far, it's been reliable. Of course, we got a unit built out of stainless steel, and you wouldn't do that in a production model. We're hoping that the weakest part of the system will be the electric motor, but because it's the only moving part, other than the compressor. The fuel cells have been tested through the equivalent of over 500,000 miles of driving, and they're still in good shape. That's on a bench. Yeah, it's on a bench in the lab. Right. Bouncing down the road, we may find out that it doesn't apply.
Atmospheric air or pure oxygen?
Those tests were actually using pure oxygen.
So you could have catalyst poisoning?
Yeah, we could have. I think we've run enough on air, though, that I don't anticipate that as a problem. But maybe.
Is that the most likely failure mechanism for the fuel cell? Ignoring the compressor issue,
the failure mechanism that we've had the most trouble with so far has been a manufacturing quality problem. If we don't get the material put on the membranes properly, then we'll have a place where it will burn through and it'll overheat and make a hot spot, and then we'll short out one of the electrodes. That's been the biggest problem we've had. Since we went to the laser, that hasn't happened yet, but we don't have a lot of experience with the laser cells yet.
Now, you are using the laser as a slicing medium?
No, we're using it as a manufacturing tool. We don't actually slice with it. It's not that powerful of a laser. We're using a YAG laser that's about 50 watts. But
it's an etching medium then?
That would be closer. It doesn't quite describe it. It's a little bit proprietary, but that's better than slicing. Okay. Yeah, I think you got it figured out.
How long between turning on the key and driving down the road?
Instantaneous. Yeah, the startup is probably about 15, 20 seconds.
And you're strictly hydrogen, you're not getting started or using electric for certain kinds of propulsion?
We have lead acid accelerator batteries in the system. This is the one for the 12-volt system, and we have one behind the seats. It's a series of them give us the 100 volts for the...
What's the function of the circuit board right here, too?
The control computer controls the whole hydrogen system. We have hydrogen leak detectors, we have temperature sensors. When the temperature gets up to 120 degrees Fahrenheit, it turns on the cooling system. So it controls the whole system.
What is the cold weather startup performance?
It's not a problem. You still have positive hydrogen pressure in the hydride down to freezing and below. Actually, all the way down, probably liquid hydrogen temperatures at 422 below zero. So the problems we have with cold weather right now are we produce water in the fuel cell. The fuel cell is full of water. We're not sure what's going to happen if you freeze the fuel cell. And right now we have the system so that we run a trickle power generation if the temperature gets down low. And if you do that for months and months, it eventually use up your hydrogen. You don't need much to keep it from freezing. One of these days we'll get an extra and we'll try freezing it and see what happens. But I'm afraid it will damage it.
I heard you say a few minutes ago something about the chlor-alkali process. Would that be a diaphragm cell?
Where they use the membrane?
Right.
No, electrolysis of brine to produce chlorine and hydrogen.
Mercury type process.
No, it's just electrolysis of seawater, actually very pure seawater, salt water, to produce chlorine on one electrode and hydrogen on the other. Okay. Then they use the chlorine to make whatever. Yes, we do filter it, and we may not be doing it good enough. We don't know yet. We don't seem to have a problem from the point of view of it hurting the membrane material, but if you operate in a real dusty climate for a period of time, you may plug up ducts or something with dust. And so we do filter it, and we may find we need to filter it better.
For particulates, not for gases?
Yeah, for particulates, yeah. Impurities in air I don't think are going to be a problem to us from a poisoning point of view. Our membrane's very robust. Fuel cells traditionally have been phosphoric acid devices. And if you sneeze in the room where one of those are running, they're poisoned. I mean, they're very, very sensitive. If you just let it sit for a couple months, it's poisoned.
You can't drive through Gary, Indiana.
You can't drive near Gary, Indiana. But the proton exchange membranes are really robust. The backbone of the membrane is Teflon, and the stuff is used to make chlorine. It's really a gutsy material, and as a result of that, I don't think there'd be anything in there that would really be too much problem to us.
You talked about a catalytic reaction in the fuel cell. There's actually noble metals in it then?
Yes, we do use noble metals.
Mm-hmm. Platinum, palladium, rhodium. You talking about which ones or not?
Well, in this particular fuel cell, we're using a very light loading of platinum. We're not using any iridium. We use a very thin layer of iridium over the platinum on the anode side of our electrolyzers, 1 atom layer thick, to get rid of the oxygen over voltage. But in the fuel cell mode, we don't need that. Of course, it's expensive. We do something very interesting in this unit that cuts the platinum loadings to about 1/10 of a milligram per square centimeter, which is low enough that it's not a major cost problem to us.
Mm-hmm. Has this car been driven under road conditions for testing?
Oh yeah. In fact, we're going to drive it in just a minute. Mm-hmm.
Passenger?
Yeah, we have about a cumulative 600 or 700 miles on it now.
Right.
Mm-hmm. And if we can stop exhibiting it long enough, we'll get a lot more.
Do a lot more.
We've had a lot of interest in it. Most of those miles have been driven by executives of auto manufacturers or so forth. A lot of it hasn't been scientific testing yet.
Do you have any special storage container for the hydrogen storage in the back?
The hydride, you mean?
Yeah.
What about it?
Is there a special storage container?
Well, it's a powdered hydride so that it's non-flammable hydrogen, which makes it very safe and also makes it a lot more compact and low pressure.
Yeah, low pressure. What kind of pressure?
It operates at between 40 and 60 psi.
Versus hundreds of psi if it's straight hydrogen.
Well, if it were a compressed hydrogen tank, it'd probably be 2,000 to 6,000 psi because hydrogen doesn't liquefy with pressure. So if you want to get it in a tank, you just keep raising the pressure until you get enough to go somewhere. So it's a real problem.
This pressure is what?
60 psi, 40 to 60 is what we operate at. We recharge at 250 to 350 psi, anywhere in that range. If you want to do a real quick 10-minute recharge, you do it at 350. And then once we start using it, we operate at 40 to 60.
If you extend your range, you could easily make a stronger tank and raise the pressure and get.
Wouldn't give you very much more because the tank's clear full of powder. There's very little void space. So if you want to extend the range, just make a bigger tank with more powder. So this is only a 250-pound tank, and that tank has an inch of insulation around it. So it's really a very small. They're very compact. They're not much bigger than a gasoline tank, but they're a lot heavier.
Do you feel that the federal government is doing everything they can to encourage these developments? And do you have any opinion as to why they're doing what they're not doing?
May I restructure the question? I don't think the federal government's doing anything to support this technology, to tell you the truth. The last couple of years, Congress has put a hydrogen energy rider on the budget allocation for DOE, and DOE still hasn't spent any money on hydrogen. Somebody doesn't believe in it, I guess.
Would you like to take a wild stab as to who that person is?
I don't know.
How about Detroit, the big three? Are they dabbling in this at all?
Fortunately, they are finally.
Dabbling?
Yeah.
Dabbling.
When we announced this car, we were contacted by almost every major auto company in the world, which is a real first for hydrogen. I mean, usually we're just cursory ignored. And this time, I don't know, with the rules about the zero emission cars, the legislation in place, and with the efficient, for some reason they're interested this time.
How does this system compare to the onboard production of hydrogen to just power the internal combustion engine?
I mean,
is that viable?
Something for nothing, you black box, pour water in and make your own hydrogen, no power.
Right.
I don't think those are real. I've seen a lot of them.
Yeah,
I've even explained to a lot of inventors what's really happening. Most of them, they have a metal inside of the black box which reacts with water, forms the oxide of the metal and gives off hydrogen. And they come to me and they say, Roger, I've got this breakthrough invention, it's free power, except I have a corrosion problem. If you can help me solve that, we'll be rich. The corrosion is the reaction, what do you tell them? It's easy to make a black box that'll produce hydrogen from water. Yeah, until you use up the metal. And you just change that plate and away you go again. But most of the guys that are doing it don't understand the chemistry of what they're doing. Oh no, the metals that you have to use cost anywhere from 100 to 1,000 times more than hydrogen.
What do you think about polymer fuel?
Oh yeah, you're talking about expensive things. This is a polymer fuel cell.
And what about aluminum air? What do you think the potential is of that versus the
Aluminum air, you're talking about batteries?
fuel cells?
I don't know about aluminum air fuel cell.
Well, aluminum air batteries.
Yeah, I think that to electric car builders, our fuel cell hydride, I guess, is a battery. We're a battery system, but we're a darn good battery. We're a battery that you can recharge in 10 minutes if you need to at a refueling station with hydrogen. And we're a very lightweight battery compared to even the high temperature sulfur batteries.
What do you think about Luz's recent announcements about zinc slurries and the like?
I don't know much about it. I'm not qualified to have a public opinion.
Well, they haven't released much information.
Mm-hmm.
Which hydride are you using?
We're using iron titanium with a small amount of manganese to stop decrepitation. Just a real...
Lithium.
Oh no. No, none of the... Well, lithium aluminum hydride and things like that are kind of a one-time deal. You can react them with water and produce a lot of hydrogen, then you got to throw it away. These are intermetallic compounds that you can charge with gas, get the gas back, and do it over and over and over just replacing the gas.
You said it was less expensive than gasoline. How much less expensive?
Well, it depends on your cost of hydrogen. If you produce hydrogen from the grid at the prices we have in Kansas City, Missouri, then we figure that for a gallon of gasoline equivalent, you have to define some terms somewhere, that it would be the equivalent of buying gasoline for about 50 cents a gallon. If you make it from photovoltaic electricity, which is quite a bit more expensive, that's about $1 a gallon. If you make it from natural gas, that's like 22 cents a gallon. So it just depends on how much your hydrogen costs.
Do you have any interest from natural gas utility people about exploring or expanding this program?
I do. Mm-hmm.
And do you think that they are going to be the natural, your natural partner in all this? 22 cents a gallon sounds pretty good.
Well, I don't know. Natural gas is a bargain. It really is. And there's a lot of push now to make CNG or LNG vehicles. But if you'd reform that natural gas to make hydrogen, they go 2 to 3 times as far for the same amount of CNG. So I think it's a good idea.
How expensive is the infrastructure in order to be able to produce that?
Well, the infrastructure's in place. The natural gas reformation devices are commercially available, skid mounted. You can put one in back of a service station, hook it up to the pipe coming under the road, and then run a little thing out to the pump and refuel cars. In fact, there's one gas company that's studying the feasibility of that right now.
How aggressive are the Japanese being in exploring all this?
They're quite aggressive. The most aggressive right now are the Europeans, which is interesting.
The Germans, BMW?
Germans, the French, and the English.
So you think that's likely to be a breakthrough area?
Well, one thing that really heartens me, I don't believe I'm saying this, but it's true. One of the American companies is showing real aggressive interest, which I waited for all my life. Never thought I'd see it. But who knows, maybe we'll do this here.
A gas
You know? No, an auto company.
And who is that company?
I don't remember their name. I don't want to scare them off. You know, if I start flashing their name around, they probably will lose interest.
Not if it's right or wrong. Is it the Tucker Company?
If a person buys
What do you think about the ABC? Do you think they're DEF? Or?
The ABC,
Yeah,
the television network? We're trying to form a consortium. We like the strategy. We're trying to get all the companies who are interested to chip in a little bit of money for the next 30 months to take it from a prototype to a production vehicle. And consortiums are a great way to go. As far as their consortium, what they're doing, I really haven't kept up on it.
Big companies only or small companies?
Anybody that's interested,
Give me your card.
be glad to.
Have one of your cards, sir?
Sure.
If
How
somebody
about
buys
two?
a bunch of
Steering wheel on the right side.
This was a post office car. It was donated to us by the post office. It delivered mail for 5 years.
What kind of car is it?
It's a Ford Fiesta, or it was. Design Factory put a new little skirt on it and fixed it up so it looks a lot nicer than when we got it.
The right-hand drive had an application to take it to Europe or England or something?
No, it was to deliver the mail.
I know, but certainly you could have gotten another Ford Fiesta to build a, I don't know how.
Well, no, the reason we liked this one was it was already an electric car.
Oh, I see.
See, we didn't want to reinvent the electric system. We just want to put the hydrogen system on. If you look, the old electric system here is 10 years old.
Prestolite motor, is that correct?
Yeah, exactly. It's an old Prestolite motor. That works good, you know.
I'm interested still in the fuel cell, which seems to me to be the key to the whole thing.
Sure.
What there are some constraints you have on the cleanliness of the hydrogen, the purity of the hydrogen, and I presume there's some danger of poisoning it with stuff coming in through your air supply. What are those constraints?
Actually, the problem of pure hydrogen isn't the fuel cell, it's the hydride.
Okay, the hydrogen.
The hydride can get poisoned if you have water, oxygen, CO2. And so when we come out of our electrolyzer, we run it through a water trap, just a liquid trap, and then we run it through a pressure swing absorption molecular sieve type step. And the electrolyzer produces enough pressure to drive all that. And so we put it in the tank about 99.9% pure.
Okay. How about on the air side, on the oxygen side?
Once it gets to the fuel cell, we have not had a problem with hydrogen or oxygen as far as impurities are concerned.
There's some filter involved in this mechanism.
There's somewhat.
Is there a filter in the compressor or before the compressor?
There's a filter right there. That's our air inlet.
Yeah.
And that's the extent of our filter right now.
But there's something in here that extracts nasty molecules. There's no need for that. You can just run straight air.
I won't say there's no need for it. I would say so far we haven't discovered the need for it. You know, but this is,
So
it's hard to make claims, you know, with 500 miles experience on the vehicle. Now, this is kind of brand new to us too. In the lab though, we've run off of oxygen and air, and we haven't seen any problems with it. The big problem is once you switch to air, you immediately lose 15% of your power.
Because they need to compress it?
No, because of the diluent effect. The cell is diluted by the nitrogen, and so it just, you know, finding reaction sites a little slower. Now, when we first built this prototype, we didn't have that compressor. We had an electric blower, and it consumed 3.5 kW on a 12.5 kW cell. And you know, a lot of times we're operating the cell like at 2 or 3 kW because that's all we need. So we're spending more energy compressing the air than we were making. And so we decided we couldn't do that. So we built this compressor. This compressor, this one right here.
Oh, this?
Yeah.
All right.
That compressor takes hydrogen pressure out of the tank and uses it to compress the air. It also recirculates the hydrogen. It's a hydrogen pump because we have to circulate hydrogen through again to get full power.
Keep the gas moving across the membranes in the fuel cell.
Right, otherwise, again, the power goes down if we don't do that. We've got to be able to, once a reaction site becomes available, we've got to get a new reactant there as quick as possible.
Okay.